In this lesson, we're going to learn about molar mass. So we learned about the mole, or 6.02 times 10 to the 23, so Avogadro's number. So that many of something represents 1 mole. And in addition to that, we can also determine the mass of a mole of any item. So we use the periodic table to determine the mass of 1 mole of atom of an element. So when we look in the periodic table, so for example, carbon is 12.01 for its atomic mass, 6 for its atomic number. So that means that there are 6 protons. And remember, this is a weighted atomic mass. So carbon 12, which we clearly have the vast majority of carbon that exists as carbon 12 because this value is so close to 12. So carbon 12 would also have 6 neutrons. But 1 atom of carbon is incredibly tiny. So the mass of 1 atom of carbon is not going to be 12.01 grams. We've always talked about protons and neutrons having a mass that is equivalent to one another, and we've given them this arbitrary value of 1 because we don't want to work with numbers that are really tiny. So if I measure the mass in grams, it's going to be a very small number, so 0.00000, and it would go on for quite a bit. So the mole, which we learned about in the last lesson, which represents 6.02 times 10 to the 23 of something, that's how many atoms it would take of any element to give us the mass of that element in grams that is equal to its atomic mass. So the addition of the protons and neutrons. So 12.01 grams, it would take 6.02 times 10 to the 23 atoms of carbon to give us 12.01 grams. So the molar mass of a substance is its mass in grams for 1 mole of that substance, or for that many. So another example, iron. If I had 1 mole of iron atoms, it would have 55.85 grams as its mass. So that is the atomic mass that we find in the periodic table. So once again, the atomic masses are based on, that is the mass in grams if we had 1 mole of the substance, and it's also based off of the weighted average of the various isotopes that exist. So if I'm looking at strontium, what's the mass of 1 mole? And so my atomic mass is 87.62. So it is 87.62 grams for 1 mole of strontium atoms. Lead, so lead is 207.2. So the mass of 1 mole of lead is 207.2 grams. Or as we write the molar mass, 207.2 grams per mole is the way that we measure that. Mass of 1 mole of nickel is 58.69, or the molar mass is 58.69 grams per mole. For strontium, so if I have 4 moles, this time I would take my atomic mass and multiply it by 4, and that's going to give me 350.48 grams. So the mass of 4 moles of strontium is 350.48 grams. The mass of 0.5 moles of lead, so this would be my mass per 1 mole. So if I multiply that by 0.5, then that will give me 103.6 grams for half a mole of lead. The mass for 100 moles of nickel, so this is my mass in grams for 1 mole, multiply that by 100, and that gives me 5,869 grams for 100 moles of nickel. So those were all different elements. We can also use the atomic mass of each element to determine the molar mass of any compound. So all we have to do is take the sum of the molar masses of each of the elements that make up the compound. So for example, potassium chloride, potassium is K, it's group 1, so it's a 1 plus. Chlorine is group 7, so it needs one more electron, 1 minus, 1-to-1 ratio, so KCl is the formula for potassium chloride. So the molar mass is potassium, which is 39.10 grams per mole. Chloride is 35.45 grams per mole. And so potassium chloride is, add those two up. So the molar mass of potassium chloride is 74.55 grams per mole. Water, so I have 2 hydrogens and 1 oxygen there. So hydrogen, 1.01 grams per mole. We have 2 of those. Oxygen, we have 1 of, and that is 16 grams per mole. So every mole of water has 2 moles of hydrogen atoms, 1 mole of oxygen atoms, and that gives us 18.02 grams per mole of water. So if I were to measure out water to 18.02 grams, then I would know that I would have 1 mole of water, or 6.02 times 10 to the 23 molecules of water. And last one here, molar mass for 1 mole of sodium chloride. So sodium is 22.99, chlorine is 35.45, and when we add those together, we get 58.44 grams.